FDR's new deal was $900 new or a deal. Discuss.
Yeah.
I copied it from Mike Myers. It was on the other night. I remember. That was actually one of them.
Nothing's ever new. IBM invented it all.
Yeah. Oh, shoot. There's another one that's pretty good. Any good jokes, you know, these days, Mark? Any good joke? Any joke?
Are we not living in a big joke?
No.
Paradise. MCP, is that the master control program?
Method canvas.
You need to get Tron on that.
Exactly.
Tron bites for the users. Are we live streaming now or?
Yeah.
Oh, we are. 2 minutes, folks. We're getting our video set up.
Professional recording.
Mm-hmm.
Yeah.
When in doubt, choose the blue cable.
We're going to cut the blue cable.
You're supposed to cut the blue cable? Don't tell me that. Would not be out there.
Okay, what? Space.
About 50%.
Come on.
I've got a joke.
You ready?
Yeah, Lesh, can you say something?
Hello, can you hear me?
Perfect, thank you. All right, Mark, whenever you are ready.
So the live stream goes to where?
Social platforms, YouTube, and
So you can watch the
under the page.
Yes. You're streaming to Cisco.
Okay.
The Cisco sponsoring.
Okay, good evening and welcome to the May 2025 meeting of BayLISA, the Bay Area Large Installation Systems Administration User Group. My name is Mark Rover. I'm the current president of BayLISA, and here today we have fellow BayLISA board members, Guy Purcell, Adrian,
Yes.
and Ron. I'm sorry, Ron. BayLISA is held on the third Thursday of every month, and meetings are open to the public. We are a membership organization, so we do encourage people to join, but it's not required. Membership fees enable us to pay for various organizational expenses, meetup.com fees, meeting refreshments and such, so that we continue to bring you the best speakers and present interesting and relevant topics. If you're an organization and would like to become a member, please speak with myself or one of the other board members after the presentation or online. BayLISA would like to thank Cisco for supporting BayLISA by arranging this space for us to hold our events. Without corporate sponsorship, it would be much harder to hold these things. Please be respectful of facilities and remember to clean up after yourselves before you leave. Unfortunately, Wi-Fi isn't available in this, so try to use cell phones. I can share mine if needed. BayLISA is a volunteer organization, and as such, the board is always looking for new volunteers. If you enjoy these talks, we encourage you to give back to the community and help. It's not hard work, but many hands make the lift easier. The board meets on the first Tuesday of the month, make plans for the general meeting, discuss topics and speakers, and generally make things better. But more importantly than that is finding topics and speakers for future BayLISA. So even if you don't have time to volunteer, if you know of someone you'd like to hear from or a subject you'd like us to find someone to present on, we'd be interested to hear from you. So again, find one of the board members or myself afterwards. We typically reserve some time at the beginning for announcements. So to start us off, during BayLISA board members announcements.
Retirement is awesome.
Don't go if you don't have to, but if you do, make sure you get to retirement. We typically reserve a bit of time for job announcements. So maybe you're looking for a job or your organization is looking for someone to fill a job. We have had matches here before, so if you are looking for a job or have a job, raise your hand. You can. I don't know if any positions open there on LinkedIn. You may not there.
It just had a rip, so.
Oh, not that good. Okay, we'd like to keep you informed about other interesting upcoming tech events going around the Bay Area. Unfortunately, like a lot of tech events happened last month, so a lot of them are gone. But there are some more coming up. These are the ones I mostly said last month, if you remember. TechX North America 2025 will be held June 4th and 5th, right here in our backyard in the Santa Convention Center. It's billed as a 7 co-located event, including big data, AI, cybersecurity, IoT, all the acronyms, where you will discover groundbreaking technologies, connect with industry leaders, and equip your team with tools to thrive in the digital era. There is a free ticket, which is just for the expo tracks, and a gold ticket, which gives you access to more important tracks and backstage stuff. Early bird pricing has ended, but your vendors might have tickets, so pick them up if you're interested. I have QR codes on the back wall. If you're interested in any of these things, you just scan it. The URL is there too. ClickHouse, an upcoming observability tool that's similar to Grafana, is having a free tech event up in San Francisco on May 28th and 29th. Up there in San Francisco, there will be introductions with the founders, showcases of their product uses. Some OpenAI folks will be there. There'll be AMA tech sessions, and they're ending with a networking and rooftop reception on the Pearl in San Francisco, which sounds like fun. It's free, you know, free drinks, right? Well, we're all here. Again, while the Usenix Enigma conference is no more, this year's 34th Usenix Security Symposium is coming back, and we'll start an Enigma at Usenix Security track. Held August 13th and 15th up in Seattle this year, the Security Symposium brings together researchers, practitioners, system programmers, and others interested in the latest advances in security and privacy of computer systems. So nothing we're interested in, right? Tough crowd today. Again, early bird discounts, I believe, are not on sale anymore, but your security vendors might know of discounts, and so they can look if you're interested. Finally, Make the Fair Bay Area returns in September, billed as the world's largest show and tell. The fair combines do-it-yourself worlds of science, tech, music, arts and crafts, food, and more into a weekend of what's billed, again, the world's largest show and tell. Not held actually in the Central Bay Area, it's held at Mare Island Naval Shipyard in Vallejo, but as one of our members here can tell, it's still a lot of fun. VIP tickets again have ended, but there are still one-day and all-day access tickets. If you have nieces, nephews, daughters, sons, take them to this, and school teaches them the boring details of everything, tech and all these things. But what you can do with learning that is what this thing shows you. And it's like this fire that lights their mind. I've been taking my daughter since my older one was like 6 months old, and they love doing that thing. Does anybody else know of any interesting tech events that may be going on? You want to ask?
Cisco Lab coming up in June in San Diego.
Cisco
Live.
Cisco Live is coming up in
June. Let me tell you the exact date.
You get a pass? Free pass?
No, but I can meet you there and have a drink.
Great.
Again, a lot of these things, you pick your vendor up, networking vendor.
9 to 13th June.
June 9 to 13th, Cisco.
San Diego. Cisco
San
Live.
Diego.
Oh, San Diego.
Cisco Live. So
There are 2 hackathons this weekend.
Oh, there are 2 hackathons this weekend. Do you know?
Hackadojo, there is one hackathon for Senza
Send a
API.
Hacker Dojo this weekend. I know there's another one for Agentic, but you needed a.
Agentic is one in
yeah, but you need
500,
pass, and
500
they're full.
global.
Sorry?
500 global at Palo Alto.
500 global
Yes.
in Palo Alto is also having a hackathon.
400 Hamilton Avenue.
400 down the avenue. So you can post that on the internet, on the meetup site, so folks can see that.
On the meetup site?
Yeah.
Oh, okay.
Okay.
Just make a comment, that'd be great.
Yeah.
Thanks.
Okay, so before we really get started, we ask you to please check your phones and put them into silent or vibrate. Many of us are part of on-call rotations, and we understand if you get paid, but please, if you have to take a call to minimize disruptions, please step outside. So tonight we have 2 presentations for the low price of free. First up, one of the many remarkable applications of AI is code generation. While one still needs to understand the language to understand where AI might be hallucinating, it can be quite effectively used to develop initial code framing that might just require minor edits to complete. That has problems if the code and interfaces are actively changing. So tonight we'll be showing how we might use another solution to keep our models up to date with the latest and greatest information to develop code with. So please help me welcome Nilesh Pateria and his talk, MCP and VS Code Copilot Agent. Thank you.
Good evening, and thank you for coming. So today we'll be discussing how we can integrate MCP with VS Code Copilot Agent. This is still experimental. There is nothing that is released on this phase, so just take it with this pinch of salt. But this is the area I think we all have to keep ourselves up, because I think sooner or later, like, we are going to be competing with some of these agents to write the code. If we don't know it, we will be competing. It's better to know. That's what at least I believe. So who am I? I'm principal engineer at Cisco DevNet. I've been working on some of the POCs for AI and trying to convert some of those POC to production. Recently, we have launched like semantic search and summarization for our API documentation for Cisco. There are a few other tools that we are working on. In addition to that, I also lead Cisco's API Insight, which is the tooling that we have built to ensure the quality of all the Cisco APIs and kind of measure it. It is used by almost all Cisco BUs before releasing APIs. Finally, as part of DevNet or developercisco.com, I also lead the hosting of Kubernetes-based cloud platform as well as microservices that is built on top of it to serve all the services. So I would be surprised if you have not heard of like VS Code GitHub Copilot. Hopefully you have also tried it, but if not, I think it's AI programming, peer programming, what they are trying to claim. It allows you to suggest code. Initially started with like chatting. Now it's like they have multiple modes. Recently they have released multiple modes. You can ask, where you can ask the questions about it. Also now, if you have a larger code base, you have an edit mode where it understands your existing code base and you can try a kind of refactor it or modify the code. And the third recently released is kind of agent mode, which is they are saying is powerhouse mode, which kind of helps you not only kind of like modify existing file or write the hello world kind of thing they are claiming. You can kind of like brainstorm the architecture as well as like have a full-blown project built end to end. It goes beyond that. It kind of like do multiple iteration when you are building using agent. It can actually write the code, run the code for you, look at your terminal, try to fix it and iterate it and kind of. So it's kind of getting better and better in the last 6 months or so. So yeah, we need to continue using it. It definitely helps like improve the productivity as of today itself. But it also has some of the limitations. Like it is based on, if you look at GitHub Copilot, is based on OpenAI Codex model. That's what they released. Probably they might be changing it internally, but which is trained on public code as on GitHub as well as any other public content, which is what GitHub Copilot internally uses, and it uses that information and the repository information that you have provided in the workspace, and provide you various editor content suggestion and all those things. But typically, these models are updated 6 months or so, or even sometime longer. The major version of full-blown training happens like in a longer duration, and because of that, there are a couple of issues that could happen. One is like all these models are generally trained on public data only, because they don't have access to any internal data. So if within your firewall, if you have some document, or within your firewall, you have a set of APIs that you want to interact with or write code for, then it becomes challenging. Even if your API is public, if you are releasing API monthly, then it might be trained on 6-month-old API. So you may have 4 or 5 minor versions ahead, and you may not be able to, like when you write code, so it may not work with the latest version. So given all these challenges, like how do we kind of bridge the gap? So we still want to use GitHub Copilot, but can we also ingest additional knowledge to this thing? So I think 2 weeks back, they kind of added support for MCP, which is Model Context Protocol. So if you are not aware, this is like 101 for Model Context Protocol. So there have been challenges, right? So one is like LLM is pre-trained model, but there is a lot of information which is personal or like private or like kind of outdated, which you want to train. So typically there was the RAG model which is coming, so you retrieve the content and then put it to LLM. But all those pipelines are very custom pipeline that is getting built. To come up with the solution for it, there is MCP, there is Model Context Protocol, which kind of define the standard way of how the model can query your private data or your APIs or any other thing. So if you have a local data source, if you define a MCP server and client, which is in a standard way, then you can ingest your local data source content or your local APIs or like any other content that you want to do, and you can enrich your MCP client, and then finally LLM can consume that data. So it's kind of building pipeline in a standard way. Since people were already trying to do like expose their APIs and other stuff using this, it kind of picked up a lot, right? As soon as it was released only like last November, but today you have hundreds and thousands of MCP server already available for most of the things. Of course, there is a quality issue, what quality of this MCP server is, but it's kind of getting like very much traction because it's very easy to build and kind of like exposes your functionality. If you look at like if you are like, it's a very basic protocol. If you look underlying, you have a server which is wrapping either your data source or your API, and it's exposing MCP protocol, and there is a client which is calling this. Now, if you look at, so these are very basic components, but if you look at underlying, what is happening is you can either create MCP server to client using stdio, which is like you are running server and client locally, and they are connecting to each other just based on stdio. But if you want to host those server remotely, then there is a streamable HTTP protocol that you can use. So you can connect over the streamable HTTP, but underlying both of these are just using your JSON exchange, message exchange with RPC 2.0. So it's a JSON RPC extended. If you are already aware of some of these JSON RPC, then it's just like your server is wrapping up whatever content you have, and client is connecting on streamable HTTP and passing on this JSON RPC message. So you can implement your tools, what we call I want to do X, which could be a Python function. You just decorate it and say, okay, I have decorated it, and that exposes as a tool to MCP client. And then MCP client could be various things. MCP client could be almost all the IDE. If you look at Cursor or if you look at VS Code, they have now inbuilt support for MCP client. So if you have any MCP server built in, you can start consuming it. So we would be looking into that, one of those examples today. So this is what it looks like. Once you extend, you can, so in this case, you can extend your private API docs or any other content, and then it would be exposed by MCP server. Here it would be JSON, RPC, HTTP or STDI or local connection, and that is enrich your GitHub Copilot. So now it can fetch any information that you want to feed in the private doc and anything. Now GitHub Copilot can understand. It can not only understand, it can execute. So if you want to, let's say, do the git commit and all those things, if you have a git MCP server, it can call it to do things on behalf of you also. So it can be either consumption or even calling any specific action. So in this case, what we did is we kind of we have this challenge where, like, say, if you are trying to create a sample application using VS Code Copilot for let's say, for example, Meraki API. Meraki API new version gets released every month, but some of these models that it might be using is probably 6 months old or something at the best, right? So if we want to provide the latest API, what we did is we can expose our API documentation to VS Code Copilot Agent, and then it can always use the latest version of your API documentation. So we took the open API documentation, which is OS file, and then kind of like split it into it, and then created embedding server and vector database. I'm not going to it. Hopefully by now everybody has learned about bits and pieces. But this is where you create all those like index for your API documentation, and that is exposed by MCP server now. So I think we will look at a couple of use cases here. Like I will try and show you how, if you are trying to, let's say, identify orphan devices. So which could be like if you have set of devices registered to your organization, and some of the devices are attached to network, others may be unassigned till now, so you want to do some processing, so you want to create a report which are the devices which are not yet attached to any particular network. I'm not an expert on networking, I think, which is what Adrian can provide more, but this is just based on my understanding. Other one is client usage resource, which is like you have your set of client which is connected to your network, and you want to like generate the usage data, which client is using more bandwidth and those kind of things. But this is just an example, but you can kind of extend it. So let's go to VS Code Copilot. So this is like we have a very basic MCP server. We are already running on our server for our semantic search, the similar API query thing. So we just wrapped it around that thing. So we are making a call to that semantic search API and wrapped it around saying, oh, this is MTP2. So this is like probably 3-4 lines additional that you have to do to just other than you making a HTTP client call. So this exposes it as MCP server, and then this MCP server you can register within VS Code extension. So you can start seeing these are MCP server. Now there is one more MCP server, Devi Search API. But there is also MCP server debugging tool. Let's look at like what this thing is basically doing. Right. So there is MCP inspector where you can run any MCP tool locally. So I'm connected to my local instance of this MCP server, which is a basic Python script connecting to that remote. I can see, okay, what are the tools? You can have multiple tools. In this case, I just exposed the single Devi Search API. Here I can say maybe show API for camera snapshot. So in the back end, we make call to our semantic search, and it is returning, okay, these are the API, this is the API for generate camera snapshot, and this is the content of that API. It's a very simple call, which we are returning. There may be some other related API, which would be returned related to camera. So this is like MCP tool, which is making a simple call and getting set of values returned. Now, how do we use this thing in VS Code? If I come back to VS Code, let's see. So this is where we have three different modes. We have ask mode, which is for chat, kind of for chatting. Edit is for editing existing file, and agent, since we are creating net new file, we'll use the agent mode here. So let's say this is, we have registered this as a, let's take BayLISA API. I will increase the font. This is better.
Yeah.
So Devi Search API is the MCP tool that we have created and registered here. And then let's say I just want to list all devices in org. So what this is going to do is, it's going to make a call to this MCP server. So this is the call. If you look at, it made a call to remote MCP server, saying, okay, I want to list an APIs which can be served for this particular use case. And now that call returned a set of API endpoint detail document as we have looked earlier. And that API document, it kind of summarizes. Now this agent summarizes this thing, so we can look, okay, this is the device's endpoint, it does this stuff, right? So you are not blindly following it, trying to kind of like, let's say first we have find the list of devices. Now we are trying to find list all networks and devices in the network. So let's see what are the APIs for this thing. So we queried, okay, these are the APIs which are available. So it's not like blindly doing it. We can see what are the APIs for this particular use case. Now, since we know, okay, these APIs looks good, and it is already stored in the context. So we have seen this is the context for this particular chat session. So now we are saying, okay, now can you create a device? Let's start the first line. Now we are just saying, okay, given the above, let's create a orphan assigned device report. List all the devices in the organization. So basic what the logic I just want to build. So if we run this thing, now it's going to use all those APIs that we have fetched earlier, some of the details of this thing, and it created like orphan device dot list all the devices, and then should I have created. It didn't create a script. So here you can see right hand side, it created a script. So it goes ahead and it ended up using Meraki SDK. And out of that, like it can first list the devices in the organization, and then it lists devices in the org and list. So it implemented some wrapper function, and then kind of it's going through all the devices, all the networks, in each network what are the devices, and then finally identifying which are the devices which are not used for the device and find generating CSV. So like you can see, like it not only goes and you can enrich your content. So this in this case, even though like in this case all the LLM models is this API are public, are still able to do it even without that, but it may use the older version. But in case if you have some private API or some other internal doc, still you can enrich using the same process. Right, you can ingest any your personal data into this, and then can use the agent feature to kind of like still create the content or code.
But the data never crosses the network to the LLM itself.
It does cross his network. So
whoever owns that LLM.
In case of Cisco, we have our private LLM model Copilot that is approved for like our coding. So yeah, of course, you have to check for your company's policy if they allow you. In our case, like they are hosting. So
Can you repeat the question? Okay.
Yeah.
you repeat Guy's question?
Okay, the question is, does the data in this case goes to the LLM? Yes, in this case, the data goes to LLM since the processing happening on the LLM. But in our case, like we have a approved installation of GitHub Copilot where the data remains within Cisco, so we are allowed to use this particular.
You are specifically annotating in your prompt. Is that required, or if you go to your prompt, you're specifically at the beginning of it? The hash device.
Yeah, it's like forcefully calling this function, right? This is tool. Right? If in this case, I think the challenging part is like LLM already knows the API, so it will try and use its own API instead of like calling remote. So in this case, we are trying to force it to do it, but if it doesn't have that information and if you write it, like if it doesn't find that information, it will call that thing. So while you are defining tool, you have to define what that tool does is. For example, here it's the get latest Meraki API spec by querying this thing. So this is the information that it will see, okay, if I don't have information, which tool I can call. So it will call that tool, but it's not consistent in this case because it's already public API we are talking to. But if you have private data, then and better prompt, then it works much better. You don't have to give explicitly.
Thank you.
Okay.
How do you register?
Can you repeat the question?
Yeah, so sorry, the earlier question was like, do we have to explicitly give this hash tool name while calling this thing? So no, I think if your tool is unique and if LLM doesn't know, it will try and identify tool based on its description. But in our case, I think it's LLM also have partial information, so we want to forcefully call it.
My question actually was, how do you register your MCP server with Copilot?
It's pretty straightforward. Like if you look at,
Can you just repeat? Sorry.
oh, sorry. So the question is, how do we register the MCP server with Copilot? So I think that if within your workspace or globally there is a mcp.json file. So you can say .vs code mcp.json where you can list the server. In this case, this is like the API server, type is HTML, and then you say what is the command in this thing, or if you have remote URL, then you just provide the remote URL and connection. It's pretty straightforward. Even like they have built like tooling where you can go and here say I want to add MCP server, and they will guide you through.
Thank you.
Any question?
What kind of, you mentioned API usage, what are some of the other use cases where you found this technique very useful?
I think there is a lot, right? I guess like it depends on your, mostly I think data enrichment, docs, like API docs is kind of like, okay, sorry. What are the other use cases that where this technique can be used? So I think any private data, like document that is not available, because for example, internally we have a lot of APIs which we never expose, or we want to work on the coding for this thing, or we have like, we have our, for Kubernetes cluster, we have our runbooks, right, which is maintained within Wiki, and we are trying to create some automated scripting. Then we just feed those runbooks out here, and then that can be generated, script can be generated or updated in basis. So any knowledge you can do it. Other than MCP is like, there is a lot of MCP tool, like if you are looking out here at the list, there is a bunch of MCP tool. For example, GitHub Copilot, GitHub itself has this thing, Jupyter has this thing. There is web search MCP, which can go to Google and search anything, or there are various search tools. So it's not only restricted to what you have. You can say, okay, search internet if you don't find it, and it will search the internet. So it's a just plug and play, whatever you want to plug.
Question, can I connect my database through MCP and expose my data to the LLM?
Yeah.
And follow-up is like, what would that look on an MCP server? What do I need to do on an MCP server?
So MCP server is any Python.
The question is.
Oh, sorry. Can we? Can we connect to? Can we connect to a database?
Connect the database to the MCP.
Yeah,
Server.
connect the database and get using MCP. I think that is one of like I think key use cases for MCP altogether, which is like exposing your data and processing. Because MCP is not just used for coding; it is also used when you are building agents. When you are building agents, you need data to process it. But this is case for coding, so I am using it for like extending the coding logic. But at the end of the day, if you have either Python or TypeScript or any of your code, if you write a function, this is the function which is like regular Python function. Only thing you are doing is you are kind of decorating with it, saying MCP tool. What it does, it exposes that function as a JSON RPC output metadata, which is queried by the server. These are the metadata for the tools. And this is the input output request. You can also do it better, like define better input output request using Pydantic and other thing. And then you have this defined process, and they are just calling remote functions. It's like if you are using RPC, then it's just an RPC call. What logic inside it, they don't care.
Thank you.
It's just a wrapper, just to add, just a wrapper to any existing applications. You can wrap it and declare it. This is what I have, method A, method B, method C. You tell to the LLM, to the client, MCP client. So MCP client will update, give it to the LLM.
Oh, okay. Thank you.
Yeah, there's nothing new right in this protocol. It's just like it was all the old technology like RPC and all this thing put together for LLM. So it's just okay. Yeah, we are already aware of it, so people will start picking it up very quickly. Okay.
So this kind of requires a code change to make this work, right?
No, this is kind of like extended tool, but it can modify the code for you.
So you just kind of like the decorator of the MCP tool you put in front of all your functions.
Yeah. While writing MCP server, yes, you have to decorate, which is like you are writing MCP server itself. There have been like projects which is like say your API, they automatically convert to MCP server like because it's standard way of doing it. But yes, you have to write your MCP server, which is.
Well, I mean, there's certain things like Swagger, for instance, right? Where stuff documents your API and you're going wrong. Could you point this at Swagger API documentation that work?
Yeah, there is a project which is Swagger to MCP converter, and there are proxies which are coming with directly ingestion. But I think I'm taking up time from Adrian.
No.
Okay.
1 minute.
Okay.
So I wouldn't have to do this special like MCP tool thing. I just point at it.
Yeah, there is MCP tool, but especially for Open API and other.
Yeah.
If you are calling, there are like automated tool which is getting built, which can expose.
Which you might be able to see the API, but you know eventually get access to the code.
Yeah, and it is like very new. So I think they are still like recently they are releasing like how to do OAuth and authentication and all those things. Nothing is there, right? It's just getting built. So, but the thing is like it has kind of almost gone viral. Probably there is like 1,000 MCP server already created and published, and there is like hubs for MCP which is coming up. So you can find anything that can be done very quickly. Okay. Thank you.
Oh, Peter's coming back. So next up, eBPF. Anybody familiar with? Has a convoluted history. There was a PF which did packet filtering, BPF for bucket packet filtering, which made it easier to capture network traffic. Some SLRST trace, kernel application framework for coding performance data, which led to Linux having LMB there and spawned Kprobes and System Tap and the whole family of things. And then to Brendan Gregg, who arguably the single person responsible for much of what we consider tracing today. Sorry, I don't know there. What's become system performance tracing has become a sandboxed internal environment where one can run just-in-time compiled programs that can do everything from network tracing, shaping of its predecessors to the application system performance monitoring we do today. If you find your understanding of eBPF lacking, then you're in the right place tonight, though. So please help welcome our own board member and Cisco employee, Adrian, to give us this presentation, Introduction to eBPF.
Thanks, you guys. Right, so this is going to be a pretty short one because we wanted to do 2 presentations in 1 hour, so it's kind of really just an introduction. First of all, thank you all for coming. My name is Adrian. I'm a developer advocate with Cisco DevNet. I'm a colleague of Dinesh, of course. He's on the engineering side. I'm on the developer advocate side. And we're going to talk about eBPF tonight, like Mark was saying. So you can interrupt me at any point with questions. I want this to be interactive if you can make it, right? So no problem at all over there. The agenda is what is eBPF? Quickly, a couple of slides. Then we'll have a hello world. I'll show you just the simplest thing that you can have, the simplest piece of code to get to see eBPF in action. Then I'll show you eBPF for networking, of course, from Cisco, and then conclusion at the end, a couple of, actually 1 slide with just an overview. But first of all, before we jump into this and get started, how many of you have worked with eBPF before? Mark? Oh. Okay, so then it's really familiar with it. That's good. So you're in the right place. So then what is eBPF? Like Mark was briefly saying, it's based on the Berkeley packet filter, but it's the extended version of it, right? So BPF, Berkeley packet filter, all the way back to 1994, was developed initially as kind of like a filter, right, as a firewall type of thing, where you could inspect traffic packets and drop them. And that has evolved over time, of course, and we have now eBPF that's kind of a name for the community mostly, because if you start programming with this, everything is still BPF, right? So you'll see all references within the libraries, within the code, they're still just BPF. So eBPF, the enhanced naming of this just for community purposes, but as you start working and coding with it, everything is still BPF. It was introduced in 2014 in kernel version 3.18, so since then it's been enabled on all Linux kernels, right? So it's there, it's running for you, it's ready, available, and it makes the kernel programmable. And we'll see in a couple of slides what that means. And allows dynamic changes to kernel behavior, right? So you can actually do kernel development on the fly, make it start processes, make it look for specific information that you need to. Within the kernel itself, what process has been started, what file has been moved or copied or started at one point, so it can monitor all of this and give information within the user space for all that behavior. It enables, of course, high performance, low overhead, because it's at the kernel level, you have access, wire speed access, basically, to the NIC, right, the disk, the memory, everything. So the performance compared to applications that run within the user space is it's much higher, it's much higher performance when you use eBPF. Use cases for observability. So you want to make sure that, like I said, you see what's happening within the application, within your server itself. You can observe everything that the kernel has access to. For networking purposes, of course, security, you can build still filters, firewalls with it. You can have meshes. You can have it integrated with Kubernetes. We have Meta, Facebook, that has used eBPF to develop a layer 4 load balancer. So every single packet that goes to Facebook today goes to a layer 4 load balancer that's based on eBPF. And so that's just something that I think is called Keras. So the carrier's load balancer is based on eBPF, and they're using it extensively over there. So important concept for you to know here, user space versus kernel space. Right? So the user space is where we as user of the system have access to the system where our applications are running. And then of course there's the kernel that controls the files, memory, disk, network card, right? Everything, all the hardware, mice, monitors, GPUs, right? That all controlled by the kernel. And that functionality of the kernel is provided within the user space through system calls. All right, so everything is abstracted, which is nice because as you start working with the kernel, there's several SDKs, right, that abstract everything, and they provide the user space nicely organized functions, right, that you can just use, and they call system calls to interact with the kernel. So without eBPF, how it used to be back in the olden days, if you want a new feature to observe an application, right? So you would go as an application developer, you would go to your kernel person, and you would tell them, hey, I need this, right? I need my application, I'm developing it, and I need specific feature within the kernel to observe my application. So the kernel developer goes and he's going to try to convince the whole community. He's going to go to Linus Torvalds and say, you know, we have this fantastic application. We want to have it in the kernel, this specific piece. Community looks at it, right? Linus looks at it, and if everything, the stars align, then it's approved. 1 year later, you know, it's done. The actual kernel now supports this. Once the kernel supports this, it's going to take 5 years for all the distros to get that kernel into them, right? So your Fedoras, your Red Hats. So 5 years later, your application developer, right, finally gets their required feature for the kernel, but they already moved. The application is gone probably or changed. So that would be, you know, it's taking quite a bit of time if you were to go to change the actual kernel with the community. Now using eBPF, let's say application developer goes to the eBPF developer, tells them, hey, I need this specific feature to monitor my application. And then a couple of days later, right, the feature is ready. You don't even have to reboot the machine. And you have the visibility, whatever feature is required, without having to go to the community to ask Linus for permission and all of that. So then hello world, how it works, the simplest piece of code. I have this in Python. So in Python, there's a library called VCC that's going to give you the BPF class, basically, component over there. As you write code, code within the kernel itself, of course, is C, right? So it has to be C code. This is a wrapper in Python for basically this C code that's going to get executed within the kernel itself. We have here an instantiation of the BPF object. We call it the program. Basically points to this piece of program, right, to this C. And the C program is the simplest thing that you can have. It basically prints hello BayLISA. And then there's the connection between that syscall function exec VD. So this specific syscall, system call, monitors every single application that gets launched within the kernel, right? So the kernel performs thousands of different functions every single second, right? So this is going to monitor for every new process, basically, that gets triggered within the kernel. And then with attach kernel probe, it basically brings together your program with the system call, and trace print brings back that hello BayLISA into the user space itself. So we have here also how this looks. Right, we have in the user space your Python program that was that C code actually gets deployed within the kernel itself. Whenever an application is launched, that application gets triggered. hello world, well, hello BayLISA is printed, and that is actually saved in a file that's in the user space, and that's how you get access to that information from the user space itself. And you print that information to the user. All right, so demo for this. Let's go. And by the way, this, I have this, I don't know if you folks know, but there is a book that Liz Rice wrote, fantastic book. Let me see, where is it? Called Learning eBPF. See, I have it from pretty much from their languages and everything. You can get it for free from isovalent.com. It is 238 pages. They just need your email address, and you can download it for free. It's a fantastic resource. Not only the book is free, but Liz Rice, the author, has also set up a GitHub repo. And that's what I actually have here, the chapters from that book. And this is the piece of code that we're going to run, that hello world, basically from that book. So now to run this, you need to be root, right? Because you're interacting with the kernel. You can't do it from user space. So you have to do it as root, Python 3, hello, hi. There you go. So that's monitoring. If I do here, like an ls or something, bring working directory. Those are a bunch of processes running in the background, CPU usage, that shell. There's lots of processes going on in the kernel at all times. And we're capturing those through the syscall execv. We're printing hello BayLISA for every single process that gets spawned within the kernel itself. Right? Yes. Question?
The output is being saved to a file and then read back.
Right.
And is this efficient enough for doing
this
load
is
back?
the simplest way. They have maps, they have other concepts, right? We're not going to get into that. But they do have better ways of transferring the data from the kernel space to the user space, right? There's a concept of eBPF maps. There's, the question. The question was, what was the question?
Yeah, so the output is going to a file
Right,
and
so
then
the output, yes. So the output is going to a file. So where is the output going? Like we were saying, the output of this is going to a file that's in the user space. Is that efficient? No, it's not efficient. This is the most basic thing that you can do, save it in the file, access from the user space. There's, like I said, concept of eBPF maps. There's memory that you can save it in and access it much more efficiently. Yes, good question.
In security, it goes to another server. They analyze the packets for security.
For security purposes?
Yeah. There's this eBPF based security, a cybersecurity product.
There are. So are there any, the question is, are there any security based
That's
products?
not a question, I was just adding a point.
Oh, right. So a comment, yes, there are a lot of security products that are using eBPF because, like I said, there's the performance aspect of it. You get access to the kernel itself, right? And then you can use it security purposes, firewalling, intrusion prevention, right? You can enforce. I'll actually show you in the next demo how you can intercept ICMP packets and drop them or allow them. All right, so that's our most simple hello world, right? So you would have to write that C code that gets executed within the kernel itself. And in this case, we have a nice Python wrapper to make it easier to work with eBPF. Now going back to our slides. eBPF for networking. Security is one use case, networking would be another one. There used to be, I don't know these days, but I don't know if you folks remember, I'm sure some of you do, the packet of that thing, right? You would get like crafted packets in a certain way and you send it to a server and it would bring the whole server down because you would not expect the exact format of the packet, right? So I don't know if it's still a problem. I think it still is, but it used to be a big problem with these packets of that you can craft them and just send them. You would cause memory leaks or you would overload and nick. So you could send these packets of that, right? And then what you do? Since this happens, you have to wait for the vendor to patch it, right? Somebody to fix that. You have to update the server. How much time is that going to take until that fix comes? Who knows, right? It could be a week, a day, a month, 6 months, whatever it is. Or, I mean, you could use eBPF, right, to look for that specific. You build a simple eBPF program. You look for that specific type of packet, and you drop it at the kernel level. You don't need to wait for the actual vendor, whoever it is, or the actual kernel people to fix that specific box. All right, so you can do it within minutes. Fix that problem. And then let me show you, like I was saying, the ICMP example that we have here. Chapter 8. So let's have a look. This is the code. So this one sources a file called ping.bpf.c. We'll have a look at that one also in a bit. It connects to the loopback interface on my Linux server, loads the function, and then attaches the interface to that function, and trace prints, and then 6 exit when we do a keyboard interrupt. And that C program in that case looks like this. So basically, there's a simple XDP function that looks for ICMP ping requests. Right, so it prints that ping packet, and then it allows that traffic to go through. So let's run this. Sudo free ping. Okay, and then we'll ping 127. Right, so it captures, it detects that ICMP traffic and it prints got ping packet. And now I can modify it on the go, right? That's the fantastic thing because I can do XDP deny. Go ahead again. Or let me see, it's XDP. Drop. I got the ping packet. As you can see here, it's stopped. There's no more replies. Right, so we have sequence 56, and that's it. It's capturing them, and it's just dropping all those packets without having to reboot the server, without having to do anything, right? So it's dynamically transforming this. And if I go back to pass.
But before you start the pass, if you just stop the Python terminal running, it's still running in the kernel.
That's a good question. Let's give it a try. It's still, well.
The agent is running in the kernel.
Yeah, so you're not getting pinged.
Right. So you're not getting the piece in there.
What was the question?
Makes sense.
No, I'm just pointing something out, that, the things are running even without the things running in the kernel. When you start it, it keep running, please.
So Mark's point of clarification is, can you summarize it? What's Mark's clarification point?
Right, so even
I
if you
get
stop
about
it,
actually.
right, it's still running, and you see here it's back at 1.1, so we're allowing again the traffic. But even if you stop, it's still the program is still running in the kernel.
So Python just effectively had this C code compiled and injected into the kernel.
Correct.
The kernel is now running that. If you
Yeah.
stop your Python code, nothing else happens. It doesn't matter. The kernel has, right? The kernel doesn't know anything about C. So there's a
Doesn't know
bunch
anything
of
about
wrapper
Python.
stuff that you don't see that causes this to be compiled and hand it the compiled code to the kernel. The kernel can run that.
It's just a execution law.
And so it's still doing it.
Does anyone have a USB-C cable?
Yeah.
Mark, does. There we go.
Any other questions?
I have a question.
Yes.
So, and you can repeat it. So, could you extend it and say like, I mean, I would imagine theoretically you could say, okay, I'm seeing this traffic, I don't like it, I'm just gonna just drop the interface, but now I'm getting more than this thing. You know, like bombarded, maybe a DDoS right, type thing. You could have it actually maybe trigger dropping that interface, right?
You could, yeah, so the question is, could you have eBPF stop the interface, like shut down the interface? Yes, you could do whatever you want.
I guess I was just thinking like, what are the other things beyond, like what are the next things you could take it? But I guess anything you could access the kernel to execute, you could do.
Yes.
Could you briefly explain what's the safety mechanism that stops somebody from actually taking down the server?
Right, so that's a great question. The question is what safety mechanisms are built into this not to bring the server down, right? Because you could have eBPF programs that are malicious, right? Or they could actually bring the server down. Well, there's the concept of an eBPF verifier, right? So that verifies that there's no loops there, right, within the code itself. Basically, it does a sanity check before it actually allows the code to run within the kernel itself, right? So yes, you have to be, of course, careful if you start running this because it's at the root level, right? So if you just grab something off of the internet and you run on your server, then you're on your own at that point. Or you have to be very careful what type of code you're running. But besides that, there's the eBPF verifier that actually goes and checks and makes sure that there's no loops, there's no infinite cases or issues with that code that could cause the server to come to be brought down.
Did that automatically happen when you loaded the code?
It did, yes,
Okay.
yes.
Thank you.
Yeah.
And before that, do you not have to be root first?
You have to be root first, but the question was even if you root first, right? How do you make sure that the code itself is not malicious or bringing the server down itself? But there's the eBPF verifier that does that, and if it detects at any point that there's any issues, it's not even going to run the code. Yes.
During your development, what kind of testing do you do? Do you run them inside a KVM simulator or something?
That would be a question for the people that develop this. I'm not developing it. I'm just talking about it. But I would imagine that they have test environments, right? Different types of servers, different versions of kernels. They would run this and make sure that there's all types of service meshes that are being developed, right? As you start getting more advanced features in networking, then this is where the value of eBPF comes. There's companies like Isovalent, there's projects like Cilium out there, right? There's SpiderWeb, what was I talking with? Right, that they use eBPF to develop products, security products, service meshes on top of eBPF. Yes.
Yes, just a clarification of the question he asked. The verifier is built into the kernel itself.
Right.
So whenever you make that function call you show, it will automatically go through the verifier.
Correct.
Before it is deployed into the kernel.
Correct.
Okay, thank you.
Yes. Okay, so conclusions, right? Basic programmable. Yes, Guy.
I just want to make a point about what Martin asked, right? And security. So the eBPF code was injected into the kernel and it's running, but there's no evidence of that anymore, right? You don't know. You log onto this machine and that stuff is running in the kernel and you have no idea that it's there. So from a security standpoint, that's it's tricky. Right?
So, I mean, doesn't it, so it's sort of like a one-shot, sorry, it's an enhancement of your question, if you will. So program you execute, it's a one-shot. It's execute and it ends. It doesn't, there isn't any trace of it in the kernel once it's executed, correct?
It lives there.
It lives there, right? It's running, it's listening for events.
The question might be, is there an audit
Yeah.
of what got injected?
that's it.
Because essentially the kernel runtime, sorry, I know you're like, I just do this, so I'm not gonna get
Yeah,
It's a good
yeah.
discussion though, I mean, because
Yeah.
the thing is like, something gets shoved in there and it's like, okay,
What's in there?
was never here. It's like, you run
That's
this
one
thing,
of-
it's like, cool story, bro, see you later.
That's funny because that's one of the main use cases for eBPF, auditing what happens in your kernel, right?
Yeah.
So the irony of it, right? Is because you use it exactly for this purpose. Most people use it for auditing purposes because they want to know exactly what processes are running on that. So if there's a process that comes and, and it's what happened because we're not expecting this. So eBPF will pick it up automatically and it will show it to you. So that's one of the main use cases of eBPF, funnily enough, right? Auditing what happens on your server at all times because it has visibility into all processes, right? So whenever there's a process, another eBPF program that gets triggered, like we've triggered the ICMP one, right? It will trigger it automatically. So we'll have another eBPF program watching what happens, all the processes within your kernel, right? And that's one of the main uses of this is because you want to tie down as much as possible that server and have it run only approved processes or applications that you want, right? Anything else is not allowed, basically.
It's a fascinating question, that a very important one, that you can audit other things, but you can't audit the auditor itself.
You can, right? So if there's, like you were saying, you audit everything, and if that ICMP program that we've run is going to show up as an eBPF program within your auditing system itself, right?
There is a BPF tool that will show you what running programs.
Oh, okay.
There is a way of seeing that.
Okay.
You can
You just
find
have to know to go to
Yeah.
right?
Okay. Okay.
Well, if you start using EBPF programs, you really should have something monitoring.
Okay.
So basically a cron job that runs and says, send me an email, the output of this thing every 15 minutes.
You could write an EBPF probe that watched for EBPF program, right?
So I have a dumb question. This is a kernel feature, Linux kernel feature.
Yeah.
Is there a way to disable this? Like say you're paranoid and you don't want it to, or do you have to like compile the kernel with the flag?
No, it does need to be compiled in the kernel. In fact, even when you said that it was available in those versions, like AWS was not making it available in the default kernels for a very long time. You had to recompile it yourself.
So you have to have an instrument that compiles.
A lot of distributions compile it by default by now, but you could recompile and take it out.
You mean eBPF program to be compiled with the kernel, you mean?
Yeah.
No.
Yeah, feature
What
that.
if
No, 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 no.
No,
It's kind of agent.
feature flag, kernel feature flag.
It's kind of agent. You just, any observability agents. So for example, my friend of mine, he has a company, he recently raised $2 million. So his is completely eBPF based observability, security, cyber security. So he puts an agent. It's an eBPF agent, that's it.
Well, they still have to talk to.
And the problem, he couldn't find the investors for a long time. He was YC founder, and then after that they couldn't find investors for long because of the security issue with the eBPF. They couldn't, nobody trusts this is not going to work. So right, I mean, it's a security vulnerability. So that's how the companies were looking at it. Like I said.
I don't understand how this doesn't lead to tainted kernel for people who are tracking
So
for tainted kernel.
they put it like agent right now, and then they privately collect, securely collect the
But
information.
if the kernel doesn't have the extensions that you get from file into it as module or file directly into it, you make those calls and won't do anything.
eBPF works that way, right?
Yeah, so you can take eBPF out of your kernel.
Right, yes.
You can recompile it and say, I don't want this. You can.
No, you are saying the whole kernel is created with the eBPF. My agent, if I have my eBPF code, are you saying the eBPF feature or
The feature itself, yeah, the ability to use it.
eBPF is a yes.
Yeah.
But my code is
So if he's super paranoid about a server, he doesn't want anybody using eBPF on his server, he can recompile his kernel and say.
exactly.
Yeah.
And it's yeah. This is
So-
a feature
so-
of the kernel, right?
Yeah.
It is a feature of the kernel at the end of the day that you can disable.
So I noticed you're using a MacBook, right? So does
Yeah.
that run natively on the MacBook as well? Or were you?
No, eBPF is.
No,
a-
it's Linux. It doesn't work on Windows also, so Microsoft, I mean, I know they were working on something similar. I
No,
know that-
my question was, I
The
see you're
Mac
using a
itself-
Mac, right?
Yeah, but I have a virtual machine.
Oh, okay, sorry, I
Linux
wasn't
virtual
sure what you
machine,
were
so what
running in the
happens-
background. That's gonna be my next,
What
okay.
happens is that it's a Ubuntu.
Oh, okay,
This- It's not running on my Mac itself.
Okay.
VirtualBox, okay. You're one of those guys? No.
Yeah,
You know, it's
I
actually
actually,
quite good.
But the irony is that the Mac's core was really FreeBSD from back when. So Berkeley packet filter and BSD.
Yeah, but Apple's like,
Yeah.
you're not gonna run that shit on me.
yes,
Can you add multiple probes to the same system call?
yes.
What was that?
So the question is, can you have multiple probes associated to one system call? Yeah. And then was that a question with that?
I was gonna ask the same question, actually.
Okay.
And then also, like, I guess as a follow-up, then would it be possible to have an eBPF program that just kind of hides itself by attaching to every syscall and then just preventing?
Yeah, I don't see why not. Yeah, you could have it as with associated or tagged to all syscalls. Yeah.
Again, I don't see how this doesn't end up leading to a tainted kernel, right? Like, when I say that, because like I've worked at so many places where, you know, since TPM came along, the first thing we thought about is like, let's not make sure we can, you know, not have a tainted kernel. It's like, well,
Inside the kernel, it's a just-in-time compiler and a sandbox environment these things run in. So you're not escaping into the kernel code, but you have access to kernel methods. So you can be abusive. It's only as safe as you run the programs that are safe on it. But you have to be on the box as root, or unless you're using his agent to do it.
yeah, I mean, I guess it's not, I guess when I think about a tainted kernel, why do someone care? They don't want something to be abused, or they don't want something installed, a kernel that's not for behaving, like doesn't have doesn't have a backdoor, doesn't have a way to take advantage of the system. But this feels like backdoor capability, essentially.
And it is. It is.
It's a vulnerability, definitely.
But it
No,
goes back to the.
just a comment, like, we use like kernel modules, like everywhere, and it's sort of similar, right? Like, if you make some changes in the kernel module, it can take down, you are running inside the kernel.
But those things are artifacts, and they can be signed, and they can be, right, like you can basically have the system hardened ahead of boot, right?
Right.
So what I'm getting at is like, this is runtime modification that is kernel level. That's what I'm not trying to be a stick in the mud. I'm just saying, like, if I'm playing the other side of the card, it's kind of interesting to kind of think about.
You know, when Adrian was talking about fake people doing this, you know, one person actually did make a proof of concept, very basic serve stack web server in eBPF. So I mean, a web server in eBPF is just as insecure as running Apache and root on your host. So
Yeah, I guess what I'm getting at is, all I'm getting at is like, if you expect your system to look and feel a certain way from a security posture at boot time, this probably flies in the face of that at some point.
Yeah.
If somebody has proper
You have to be
privilege.
careful.
So that's what comes back to the audit piece. That's what makes me question if there are tools to kind of, but then again, if somebody doesn't know what to do or they don't instrument that properly, I don't know. I mean, it comes back to the same thing like anything security. If you've got physical access, all bets are off. If somebody has root, again, it's like, okay.
All bets are off. Yes. So
Or
I mean,
minus RF, have fun later.
So let us put it this way. So how is the adaptation of eBPF?
how's the adoption
Yeah.
of eBPF? Well, like I said, well, Facebook is going through eBPF, right?
Very few people, right? So it's getting started, right?
Oh, no, it's been there since 2014, and it's actively, I mean, the community, and there's not only eBPF, but like I was saying, there's iSurveillance, there's all these companies that are developing products, security products on top of eBPF. Right, so
Yeah,
Cilium, there's the CNCF.
That's what I'm saying. So he
Your
found,
friend probably, right?
he found it very, it's just now getting started. So there are not a lot of applications that do deal with the eBPF directly because he couldn't get like someone to try this. You know, because this is vulnerable, so we don't want it. He had been rejected
It's
many
been there
times.
for 10 years now.
10 years, no, look, one
No,
thing.
it is there. It is option is
It's
there.
more than 10 years, but 10 years ago, Oracle was making eBPF
Yeah.
K-probe traces that eBPF could collect, and you could monitor the internals of Oracle.
Absolutely.
You know, this has been, there are a lot of people using it.
It's been
It's hiding, and it's not necessarily everybody's face, but and I was saying, you used to not be able to find kernels like on AWS, they just didn't have it, they recompile it. All of AWS modern kernels come with eBPF enabled by default now.
yeah. That's another question I have.
And I imagine.
So most images were built with kernels built by default. It comes with eBPF.
Correct, yes, yep. And I mean, like I was saying, there's all these companies using eBPF to build products, right? Service meshes, security, appliances, right, with eBPF itself. I mean, Cisco acquired iSurveillance a while back, we're talking about, right? And you'll see eBPF actually within Cisco products like HyperShield, right? Running on every single port of switches, routers, right? You'll have the eBPF agent running there, intercepting traffic, enforcing policy at the port level, right?
It's in iOS?
No,
Never mind, I mean Cisco iOS.
Oh.
Sorry, Mark.
The real one.
Oh, the original iOS, baby. The original. Capital iOS. Capital.
So like I said, there's products that are coming out. One of them is HyperShield, so Cisco HyperShield.
You can't disclose if it's in iOS.
I can
You confirm or not?
Cannot confirm nor deny.
all right.
I'll
Any
drop
other
that
questions? This is a good conversation.
We'll edit that out.
Right, so makes the kernel programmable, allows dynamic changes like you've seen, right, on the fly. And going back to your comments, Ron, right? So yeah, they give you freedom to do pretty much whatever you want, but with great power comes, you know, great responsibility. Be careful, you run all this code as root, right? At the end of the day, so you know, root, and then you have root access to the kernel. So just be mindful. You have power, but there's also, you know, responsibility that comes with that. Enables high performance, like I said, low overhead, and then used for observability, networking, security, and so on and so forth. All the products coming up. Thank you very much.
Hopefully you got some good eBPF information. I would point out that Liz's book that you pointed, Learning eBPF, really good book.
Yeah.
I'm picking out pre-order mine if you want support stuff like that. You know, it's nice to have free books. You support Liz and her work.
Exactly, yes.
Buy the book. It's a really good book. It does have a lot of information there. Thank you all for showing up. We are always grateful everybody comes to join us. We're still working out next month's. I'm not sure what we're doing, but keep an eye on the webpage. And thanks for coming.
And if you are interested in speak and present a topic,
Yeah, I'm just saying, if you have a topic you'd like to speak, if you have a subject, somebody you'd like to hear,
yeah.
come up, talk to us. We're
Very nicely done.
more than willing to have you come talk.